Here's the problem 3.12. A swimmer dives off a cliff with a running horizontal leap. That 510 newtons is completely irrelevant information. Um, this is kinematics, which we don't need to know anything about the forces, and 510 newtons is the weight of the person. We don't need to know anything about forces. In kinematics, we can work everything out. So what must her minimum speed be just as she leaves the top of the cliff so that she will miss the ledge at the bottom, which is 1.75 meters wide and 9 meters below the top of the cliff. So the important point is that this person travels horizontally initially and has no vertical velocity to start off with. So all the velocity is horizontal and it's v0. It's just is what we're looking and is what we're trying to find. And we know that this person must hit this point in a certain time that takes them to travel out this distance, and also they drop 9 meters. So that means, and the time to do both of those things is the same. So what time does it take to travel from here over to here? 1.75 meters if you're traveling at a distance of v0. If you can work that out, then you have the time. That time is the same time it takes to drop, because while they're traveling that way, they're also dropping. So what would v0 be to make this happen? So this is the key concept. Key concept then is the time to travel 1.7 meters is the same as the time to drop 9 meters at minus g. So, so let's look at the horizontal situation and say to ourselves, if the distance traveled is the distance in the x direction is sx, that has to equal the velocity travel in the x direction multiplied by the time, which is the time of flight. So the distance in the x direction is 1.75. The velocity is v0, and that's initially v0, and it stays like that because there's no acceleration horizontally. And we multiply that by the time of flight. So this means if I just rearrange that, the time of flight is 1.75 divided by v0. So that's the time of flight. Now let's consider the vertical velocity and the vertical action. So a person starts here and they drop for 9 meters. So let's look at all the quantities. So u, v, a, s, and t as usual. Our usual quantities. So the initial velocity u in the y direction, initial velocity, final velocity v, the acceleration in the y direction, and the distance in the y direction. So the initial velocity in the y direction, of course, is 0, as we said. There's no velocity in the y direction initially. And final velocity in the y direction, when it comes down here, we don't care about it. The acceleration, of course, is minus 9.8 as usual, because it's gravity that's pulling it down. Now, the displacement is 9 for 9 meters. However, it's in a minus direction, because the positive direction is up. There's also a horizontal positive direction that way. The positive direction is going up. So therefore, this thing is actually going in the negative direction. So the displacement is minus 9. Now, t is the time of flight. And that, of course, is 1.75 divided by v0. So that's the time. Now, if we look at that, the u, the a, the s, and t, so which equation of motion would we choose to solve that? Of course, it's going to be s equals ut plus a half at squared. So now that we've chosen the equation, we'll decide to put those values in. So the displacement, of course, is minus 9. And that's equal to 0. The u is 0. U0 times t is just 0. That's plus a half of minus 9.8 times t squared. So t, as we know, is 1.75 divided by v0. And all of that is squared. Okay, so that's the numbers in. So now it's just a matter of doing the calculations. So when we do that, we should get minus 9 over minus 4.9, and that'll be times 1 over 7.5, which has to be squared. And all of that then is equal to 1 over v0 squared, or you can put the whole thing squared, whatever you like. So when you work that out, you should get that 1 over v0 squared should equal 0.599, and those decimals go on, which means that v0, when you do the calculation, should equal 1.29 meters per second. Okay. And that is the actual, that's the answer. So this calculation, like we always go through the same steps. We work out, we list u, v, a, s, and t. Then we choose our equation. Then we put the values, we choose our equation over here. Choose our equation, and then we put the values into that equation, and we do the calculation and find what we want. But the key difficult part here is this part here. This is the concept. What do you need to know to actually solve this problem? And this is why you need to know. This is the hard part. This is the setting up of the problem. And once you understand that, everything else is relatively easy. The rest is just calculations. But that's where the real physics and the difficulty in all of these problems comes in.